So fortunately, we still had the water treatment plant. It wasn't equipped to treat for iron. These are those rotating biological conjugates. This is that mystery building that you can see as you're coming down Highway 385, down Strawberry Hill towards Lee. You can see this kind of white tower up here. So the treatment plant is operating, and we've installed, these are now all enclosed, but these are sand filters. And one of our engineers up there, who is a former Homestead guy, figured out, actually the company that manufactures these, and most experts said they wouldn't remove iron. And he figured out a way to use them that they actually do, and now he's giving talks all over the country about it. So we removed the iron. So here's a before picture. And this is not, I didn't Photoshop this to make it look redder. This is actually what it looks like. And this is the after. So we're discharging water into Gold Run Creek, which runs into Whitewood Creek, and it's the same discharge point that Homestead used. So you can see it if you're driving up through Pluma, up towards Homestead, and up towards Lead, and you look off to your left, we have a little waterfall actually at the bottom of this. It's kind of pretty. So here we are today. Not all the mine was flooded. Our high water mark was about 4,530 feet underground. So the 3,800 foot level was never flooded. A lot of the drifts or tunnels, drift is simply a tunnel that doesn't exit anywhere. So everything in Homestead is really a drift. This is a shop at the 3,800, and you can see why scientists thought this could be ready to go. I mean, there's a hoist there. We're actually using this hoist now on the 4850, a concrete floor and really securely rock-bolted walls. And the 4850 is dry now. The 4850 had been under about 300 feet of water. We've pumped and got the 4850 dry May 13th. And I took this picture was June 22nd. We had a ceremony at the 4850 with various dignitaries, including the governor and T. Denny and a bunch of the scientists. And that's Bill Heisinger there at the Jack Lake Drill, and the lead guy who was, I think, more than 30 years as a Homestead miner. Without people like him, it would have been impossible to open this up. If you had to send, I don't care how skilled an engineer you were, if you had to go down and figure out everything from scratch, it just couldn't happen. So he's drilling a hole in here for the plaque, and thus was commemorated the Sanford Underground Science and Engineering Laboratory at Homestead. This is, again, 4,850 feet underground with the governor and T. Denny. Science is already going on underground. We have more than 15 experiments. For example, just on the 2000 level, these are small experiments, many of them related to figuring out how to build larger experiments, but we have a couple different biology experiments, and we have a number of different kinds of seismometers measuring rock movement. These two guys, this is my boss, Ron Wheeler, who some of you remember from his days as DOT Secretary of the Department of Transportation long ago. He's our executive director. This is Dr. Rick Gatesville and Dr. Rick Schultz. He's from Brown, he's from Case Western Reserve, and they are going to put the first physics experiment back in the mine. And it's going to be a detector of weakly interacting massive particles. The acronym you can see is WIMP. We actually made up t-shirts for a conference last year for these guys, black t-shirts, and it said, "Nerds searching for WIMPs." And after every presentation, people would come up, mostly younger than this, a little younger than this, and I'd say, "Where can I get a t-shirt?" That's all they want. So we had them printed up. And we sold a bunch of lead last night after Jose Alonso's public presentation. I didn't bring any today. But this is a detector to detect this very mysterious substance called dark matter, which I'd be happy to explain to you, but I see the time is advancing. It's a very complicated concept, and I don't fully understand it myself. But dark matter is about 5 times more plentiful than all the regular matter, the stuff we can see, and it's absolute. Nobody has ever detected it. And the reason they know it's there is because how galaxies move in relation to each other. And either there's something seriously wrong with gravity or the theory of gravity, or there is more mass in the universe than we can account for. And there's a number of techniques. It's not just one technique. This has been verified by 3 or 4 different techniques, that there's a lot of mass out there in the universe, And the theory is that, one of the theories is that it's going to be this weakly interacting massive particle, a particle that has no charge and that does not, that only reacts very occasionally with regular matter. And so that's what they're trying to detect. Will they? Maybe they will, or maybe they won't. This is not a concept without controversy. But the first team that detects dark matter will be almost a certain Nobel Prize. And this is what the experiment looks like, and it will go in the Davis Cavern. So there's, kind of a guy there to give you a sense of scale, and it will be large underground xenon detector. Instead of purified water or chlorine solution, it will be filled with liquefied xenon. And they're already building their surface facility here. It's kind of their test bed, where they will assemble the experiment here and test it, make sure everything fits together before they take it underground. This is an old Homestead warehouse. This is the second experiment that's going to go in. This is called the Majorana experiment, named after an Italian physicist, and it's a neutrino experiment. Essentially, it's trying to determine, like the mega detector, certain characteristics of neutrinos. The technical name for this is neutrinoless double beta decay, and it's the governor's favorite experiment because he can pronounce that. And I can also pronounce it, and I can tell you that he and I have almost identical understanding of what it means, really. But it's another one of those Nobel-level astrophysics discoveries, and they're going to be coming in right on the heels of the LUX, the liquid underground xenon detector, literally right on the heels. So, for those two experiments, we've already started expanding caverns and drifts underground. This is a jumbo drill. Excuse me. This is, remember that jackknife drill that Bill Heisinger was using to drill the plaque in? They still use those, but not for drilling holes for explosives. They use this wheel-mounted gigantic drill called a jumbo. Drills holes pretty fast. And this is one of the loaders that they lowered underground, fit it in that, underneath, hung it from underneath that cage and lowered it 5,000 feet. These guys are loading holes with explosives. I always called it nitrocarbonitrate. It's essentially that fertilizer explosive. It's not much more than diesel fuel oil and fertilizer. For the first blast back in September, and this is after that first blast, these guys are using jack-leg drills to put up rock bolting and some of this wire mesh to secure the ground here. And this is what that same area looked like a couple days later. So you can see that small drift has been enlarged to a huge drift. This is kind of a schematic. This is the Davis Cavern. This picture was taken right about here. So they've come down this drift here, and they're driving a new drift, and I think they're right about here now. And then they're going to get into this cavern and make a big cavern for the Majorana. There will be a clean room in here and a transition area for the LUX detector. And then they're going to enlarge the Davis Cavern and put that LUX detector in. And this is all happening, well, we're already starting it, but these should be in by next year. This is what the Davis tank looked like back in 1965. I took these pictures shortly after it was dewatered. You can see it's kind of red, rusted, or oxidized. Some National Science Foundation and other officials. That's Bill Rogenthien from the School of Mines, and Kevin Lesko, the principal scientist on this whole endeavor. And we've in August and September, they took apart the tank. This is one of our technicians using a plasma cutter to take apart the steel tank. And now this is what the Davis Cavern looks like.